Hello, everyone. My name is Greg Jameson. I am a senior channel support engineer at Stratus Technologies. In this video, I'll be doing a live demonstration of our ztC Edge fault-tolerant computing platform. Now, before we begin, I'd like to do a brief overview of the hardware that we're using in our demo environment today. Now, what you see here is a pair of Stratus ztC Edge 250i, equipped with server class Intel Xeon processors. So these are not industrial PCs. These are servers running the Stratus redundant Linux hypervisor to enable virtualization at the edge. And this allows you to run multiple applications in virtual machines on a single ztC Edge node. That means you don't have to go and purchase and deploy individual hardware systems for each application. These hardened edge servers are designed to operate in industrial environments or anywhere that's too harsh for a standard server equipped with fans and other moving parts. ztC Edge are fanless, but they are able to operate in ambient temperatures up to 140 degrees Fahrenheit, and they are rated for humidity, shock, and vibration. They can be DIN rail or wall mounted, as I've done here, and they are Class 1 Div 2 certified. In the upper left-hand corner, I have a standard gigabit switch to provide network connectivity for this demo environment. Now I'm going to switch to a live camera view from underneath these two ztC Edge systems. And I've positioned the camera this way so that you can see all of the ports and the lights on the faces of these two ztC Edge nodes. And you'll be able to watch as I demonstrate our fault-tolerant capabilities by reaching into the camera view and disconnecting cables to simulate a failure on one of these two ztC Edge systems. Each of these ztC Edge nodes has two connections to that gigabit switch, and that is the pair of black cables that you see on each node. One cable on each node I have configured to be dedicated to management traffic, and that includes alerts and monitoring. And the second cable on each node I have configured to provide access for the virtual machines and applications to communicate with the rest of my network. Now, in a real-world production environment, you would want a pair of switches to provide some network redundancy, but this is just a demo environment, so I can get away with having a single switch. There are also redundant 10 gigabit connections directly between this pair of ztC Edge servers, and that's the blue and yellow cables that you see here. And we'll talk about those in more detail in a few moments. But the last cable on each node is power. And that's the green connector here on each node. Now, this can be connected to the provided AC adapter that you would plug into a standard 120 volt outlet on a PDU. Or you have the option to wire these directly to customer supplied 24 volt power sources using a standard Phoenix terminal block, which is what I've done here. Now, before I get into the actual demo, I want to talk a little bit about the installation process for ztC Edge. Because Stratus has designed these systems to be incredibly easy to install. In fact, our installation guide has only 6 simple steps. Step 1, you would connect a keyboard and monitor to the node and then connect port P1 to your existing network. And at that point, you can connect the power. The node should power on automatically. Otherwise, press the power button, wait for the node to go through its boot process, and you might hear some beeps while that happens, but it's normal. Step 3, you will see the ztC Edge deployment wizard. You'll press enter to begin and follow some on-screen instructions. And then in step 4, it's just a short wait, maybe 5 minutes or so, And then you'll see on the monitor a URL containing an IP address obtained through DHCP. And you'll want to write that IP address down because we'll need it in step 5. Here, you'll use a PC or a laptop connected to the same network as your ztC Edge node. You'll open a web browser and put in that IP address from step 4. And that will let you log into the ztC Edge interface using the default admin username and password. You'll complete the end user license agreement and some additional configuration screens. And that will take you to the licensing screen. Here you'll register the system, download and install your license keys. And then most importantly, you'll change the admin password to complete the deployment. So in less than 30 minutes, you have a running ztC Edge server, and you're ready to spin up new virtual machines or import virtual machines from industry standard templates. But you also have the option to add a second ztC Edge node to create a fault-tolerant pair, just like we have here in my demo environment. With a pair of ztC Edge systems linked together, we create a fully fault-tolerant computing environment that will eliminate application downtime due to hardware failures. Now, I'm going to bring up the ztC Edge web interface. And for the remainder of the demonstration, this is essentially what you'll see. I'm going to have the web browser up with the ztC Edge interface, and you'll still be able to see one of these two ztC Edge nodes running in the background. Now, here in the dashboard screen of our ztC Edge interface, you see a really good graphical representation of our environment. We have node 0 and node 1. They're both connected to power. They're both connected to a network, and there's that direct link between them. But this system box here represents our integrated virtualization layer and replication engine. And this allows us to run mission-critical applications in virtual machines without needing a complex cluster or an expensive virtualization software. And if one of these two ztC Edge nodes were to experience a failure, something like a hardware fault or loss of power, the applications can continue to run without an unexpected reboot and without loss of data. Now, moving to the networks page, this gives us a really good overview of the network connections in our environment. We've talked about port P1, which is this guy right here, being dedicated to management traffic. And you'll see that reflected here because there are 0 virtual machines utilizing the P1 link. P2 shows 6 virtual machines because, again, I have configured the system to utilize port P2 for network communication. Now, if I needed to connect to multiple networks, or if I wanted more bandwidth and I wanted to spread the network traffic across multiple ports, I could do that by using these 4 ports here on the ztC Edge. So I could connect these to my network and then balance my traffic across additional ports. The last links on this screen are the A links, and they're appropriately named A1 and A2. And again, that is the blue and yellow cables down here. The A links create that redundant 10 gigabit private network that is used to synchronize data between these two ztC Edge nodes. So in this interface, we refer to the ztC Edge nodes as physical machines, and you can see details about your physical machines on the Physical Machines tab. Here we can see details like the serial number, active network ports. We have sensor data, including temperature and voltage, and even the health of the SSDs in each of the ztC Edge nodes. And we can also see the virtual machines that are running on each node as well. And if you'll note here, I have 3 VMs running on each node. The virtual machines running on node 0 are all named so that they end in a -01. And all of the VMs running on node 1 are named so that they end in a -02. And this will be handy later on in the demonstration so that you can see which VMs are running where. Now, there are two different ways that ztC Edge can protect your applications, and both of these are configured at the virtual machine level. So I'll move to the virtual machines page, and here you can see all 6 of my VMs running. I currently have them sorted by this last column, which is current PM or physical machine. So the 3 VMs on the top are all running on node 0, and the 3 VMs on the bottom are all running on node 1. Now, if we look at this protection column, you'll note that each virtual machine shows either HA or FT. FT stands for fault tolerance, and HA stands for high availability. High availability synchronizes the virtual machine hard disks to the partner node in real time. So if the ztC Edge node where a VM is running were to fail, the VM would reboot onto the surviving partner node. So there's obviously a small amount of downtime for the applications on those virtual machines because they have to reboot, but the process is automated and it takes 0 operator intervention. For the most critical applications and workloads, fault-tolerant mode ensures that the VM stays up and running during a hardware failure. So the VM doesn't even experience a reboot. And that's because just like high availability mode, we're synchronizing every write that the VM makes to the other node, but we're also synchronizing the virtual machine memory contents and the CPU state over to that partner node. So even when an entire node fails, there is no perceived outage at the VM, and your application continues to operate as normal. Now, enabling high availability or fault tolerance for a VM is really simple. And there's a couple ways to do it, but typically you're going to do this when you create the virtual machine. Now, this is the virtual machine creation wizard. And as you see, we can select here either high availability or fault tolerance. And while we're here, I'll walk you through the rest of the process to create a virtual machine. So we start with the name. I'm going to call this Windows 2016. I'm going to choose high availability for this virtual machine. And now we select our boot interface. Typically, it'll be BIOS, but if you have the need and an operating system that supports UEFI, you can choose that. And now we select our boot media. So this is the media that we'll use to install the operating system. It could be an ISO image living out on a Windows share or an NFS share. Or what I'll use here is a VCD or virtual CD. And this is essentially an ISO that I have already uploaded to the ztC Edge system so that I have it locally rather than having to read it over the network. And you'll note here that I have multiple options to choose from, but I'll choose Windows Server 2016. And we'll talk about VCDs a little bit more later on. But for now, I'll click Next. And here we customize the hardware of the virtual machine to meet our performance requirements. And we do that by configuring the number of vCPU or virtual processors and the amount of memory that we want to allocate to our virtual machine. So I'm going to give this VM 2 vCPU, and I'm going to give it 2 GB of memory. And I'd like you to notice here that there is an additional 20% reservation here. So for high availability virtual machines, we reserve an additional 20% of memory on the partner ztC Edge node. And that's to facilitate that replication of data from the home node to the partner node. And that's to make sure that we always have a copy of every single block of data that your virtual machine writes. If this were a fault-tolerant VM, there would also be a small vCPU reservation on the partner node as well. And that's to enable the replication of the VM CPU state, and that allows the virtual machine to continue running even when the home node fails. So I'll click Next. Here we can customize the name and the size of the operating system volume, so the virtual hard drive where we're installing Windows. I'll give this 60 gigabytes instead of 20. And if I wanted, I could add additional virtual hard disks to this VM. So maybe I'm going to run a SQL database, and I want that database to reside on a separate volume away from the operating system. This is how I would accomplish that. But for the purposes of this demo, I'm going to leave it with 1 and click Next. And here we select the networks that this virtual machine can access. And if you recall, I've dedicated the P1 interface to management traffic, and you'll see that reflected here. 0 virtual machines running. I'll uncheck P1 and select P2 where I have 6 virtual machines. And we click Next. And that's it. You can review the settings that you've provided here and click Finish to actually launch the creation process. I'm not going to force you guys to watch me install Windows Server 2016. I think you understand the process of creating a virtual machine. So I'll just cancel this. And we'll move on to importing a virtual machine. Now, this can be really handy if your application vendor happens to have pre-built virtual appliances, or maybe you're exporting virtual machines to template from another hypervisor or another virtualization environment. You have the option, once again, to select an image from a remote network share, whether it's NFS or Windows. But you can also import a template directly from USB. And this would be a USB device connected to some of these ports here on the face of the ztC Edge system. So you would connect a thumb drive or a USB hard drive there and be able to import directly from that device. But for the demo here, I'll choose Import from my PC and click Next. I'll then browse to the location of my template, which I have here. This is a Windows domain controller, and I'll click Open and Next. And here we choose whether we want to import the VM or restore. And essentially, the difference is that import means you're creating a copy of that virtual machine rather than trying to restore it to its previous state and keep that virtual machine as is. So I'm going to import. And now we need to provide the path to the virtual hard drive for this template. I have that in the same directory here, disk0.vhd. And now if I'd like, I could customize the name of the virtual machine. I will give it 1 additional processor, so it has a total of 2 vCPU. And I think I'll actually reduce the memory here from 6,000 megabytes to an even 4 gigabytes. And again, there's that additional 20% required for a high availability VM. Once again, I can change the name of the boot volume and then select the network. Now, if I were to click import here, it would launch that process, but it would take quite a while, and I don't want to hold up the demo, so I'll click cancel. But that's how you would import a virtual machine from template. Now let's talk about those virtual CDs. So you saw that I used this Windows Server 2016 virtual CD to install a fresh, brand new virtual machine. And that's a really good use case for VCDs. But you can also create virtual CDs of your applications, and that could be your industrial automation platform or your security software or whatever application that you need to deploy to the virtual machines running on these ztC Edge nodes. And you'll see here that I have a couple of those ready to go. I have our guest monitoring agent, and I have our virtual VirtIO drivers. Creating a virtual CD is very simple. You just give it a name. Maybe I want to do Ubuntu Linux. And then I would simply just provide the path to that ISO. And again, I'm not going to make you watch this ISO image upload to the machine, but it's as simple as just pointing it to that ISO image, clicking finish, and now you have a copy of that virtual CD on the system and available to all of your VMs. Let's talk a little bit about performance. Now, as I mentioned before, we have 6 virtual machines running, and there's 3 on each node. I have 4 virtual machines running Windows Server 2016, and I have 2 virtual machines running Windows 10. The 2016 VMs have all been assigned 4 virtual CPU and 8 gigs of memory. And the 2 Windows 10 VMs both have 2 virtual CPU and 8 gigs of memory. So that's a total of 20 virtual processors that I have allocated to our virtual machines. But if we come to the system page and we look at our CPU allocation here, you'll see that it reports that I'm utilizing 24 vCPU rather than 20. We have the 20 vCPU that are running in virtual machines right here. And then we have system running 4. And that's because 2 of my virtual machines are fault tolerant. And we have to have that additional virtual CPU reservation to facilitate the replication of the vCPU state. So those 4 vCPU, there are 2 assigned to each of my fault-tolerant VMs. Now, this oversubscription is possible because the virtualization layer is responsible for scheduling time with the physical processors. And each node has a single 10-core Intel Xeon processor. So between the 2 ztC Edge nodes, we have a total of 20 physical cores. And each of those 20 physical cores is dual-threaded. So we actually have 40 logical processors. So the question then is, why don't I see 40 here? Right? If I have 40 logical processors or vCPU in total, why don't I see that? It's because we have to take into consideration the impact of a node failure. If we want all of our virtual machines to survive the loss of one of our 2 nodes, we have to limit our allocation of logical processors to 20, which is what we have in a single ztC Edge 250i. So again, I'm oversubscribed here by 4 vCPU, but I want to be clear that I am not advocating for doing this in a production environment. I'm doing this here in the demo environment simply to highlight the performance capabilities and, more importantly, the resiliency of ztC Edge when it's under load. Now, if we take a look at the CPU and memory utilization of each node, you'll see that they're both running around 48%, right? They're both under 50% utilization for CPU. On the memory side of things, node 0 is currently at 60%, and node 1 is at almost 90%. And this is a reflection of the workloads that are running in my virtual machines. And let's take a look at that. So if I open up my first VM here, I'm going to show you each one of these VMs really quickly. I have Task Manager up and running so that you can see the actual CPU and memory usage. But I have this application running called Heavy Load, and this is a load generator. And I have it configured to stress the CPU and the memory of each virtual machine. So here we have a Windows Server 2016 VM with 4 vCPU running between 85 and 90%. Same thing here, 4 vCPU running at over 85%. Another quad-core VM running again at 85+%. And here's our last Windows Server 2016 VM with 4 vCPU running at over 80%. And then we have our Windows 10 VMs. And as I mentioned, they're dual CPU, and they're both running at about 70+% CPU. Going back to that first VM, I have one more application here that I want to talk about, and that is OPC UA. Or sorry, this is called UA Expert, but it's an OPC UA client. So this is actually pulling OPC data directly from ztC Edge because we support OPC natively. It's embedded in the servers. And I only have a few examples of the data that you can pull over OPC. I have the state of both nodes. We can see they're running. Status code is good. We can see the virtual machine count. As you saw before, we have 6 virtual machines. And then we can see the primary physical node, which is node 1. So this is where our management interface is currently running. And that is something that moves depending on the health of each node. So if node 1 were to go down, the management interface would natively move over to node 0. So we'll keep an eye on that as we go through our failure demonstration. And to help with this, I'm going to run a tool called Ping Info View. So what I have here is essentially a ping tool. It's going to send continuous pings from my laptop to each one of our 6 virtual machines, as you'll see here, as well as both node 0 and node 1, and our ztC Edge management interface. So I'm going to click Start here, and you'll see the ping count start to grow. You'll see there's 0 failed pings right now. And what I'm going to do now is reach into the camera and disconnect ports P1 and P2 from node 0. So I'm going to disconnect these 2 cables in a moment. And that is essentially isolating node 0 and the VMs that are running on it from the rest of the network. So we'll no longer be able to communicate with those virtual machines. And this will trigger the high availability and fault tolerant capabilities of the ztC Edge system. And what you'll notice is the only thing that will drop a ping is node 0 because we've disconnected it from the network. Node 1 and the management interface will continue to be green, and all of our virtual machines will continue to respond. And you'll be able to see in the ztC Edge interface as these VMs all move over, and everything will continue to run. So let's do so now. Disconnecting P1, which again is the management interface. And already we have a red circle. And now I'm disconnecting P2, which is how all of the virtual machines that have a -01 at the end, that's how they all get to the network. So we have disconnected their way to get to our network, but we're still able to access them. They are all still running. As you can see, there's activity on these VMs. All of them are still up and running their workloads, happy as can be. And in a few moments, what you'll notice is that the current PM column will reflect that all virtual machines are now running on node 1. There we go. Some have already started to move over. We look at our networks page, you'll see we have node 0 is disconnected. It shows red down here for node 1 because the ports are green, but it's not a complete connection because the other node is not responding. Back to our VMs, still waiting for one more VM to move over. But again, we have not dropped a single ping to any of those virtual machines. And aside from the dashboard reporting that we have problems with node 0, everything is continuing to run. OPC UA is still running, and all of our virtual machines are happy. Now, recovery is fully automated once we restore these network connections. On the networks page is where you would see an indication of that first. There we go. Now, this process does take a few minutes because it has to go through health checks. So here you can see our connections are healthy again. Our virtual machines are starting to move back to where they need to be. And at this point, I'll wrap up the demo. Thank you all for watching this video. If you'd like more information about ztC Edge, please scan the QR code on the screen and you'll be taken to our ztC Edge page on the stratus.com website.